All right, today we are tackling a programming concept that's, well, it's both beautiful and a little bit mind-bending, recursion. It's a seriously powerful tool, but let's be honest, it can sometimes feel like you're looking into a mirror that's reflecting another mirror, that's reflecting another mirror. So let's demystify this thing together.
So let's just jump right in with a question. We all know how to repeat things in code, right? You use your trusty for loops, your while loops, but what if I told you there's a totally different way to make something happen over and over again? A way that involves a function literally calling itself for help. How is that even possible?
You know, the absolute best way to get your head around recursion is with a super simple analogy. Russian dolls. You've seen them, right? You pop open the big one, and what's inside? A smaller but identical looking doll. And you open that one, and boom, same thing happens again and again until you get to that last teeny tiny little doll that you can't open. Just hold that picture in your mind. It's the perfect model for everything we're about to cover.
So, here's the game plan. We're going to define what recursion actually is and talk about its two golden rules. Then, we'll look at the alternative you already know and love, iteration. After that, we'll put them head to head, see the pros and cons, and then, most importantly, figure out when to use which one.
Okay, let's get right to the heart of it. What in the world is recursion? Well, it all comes down to two super important, absolutely golden rules that any recursive function has to follow. Get these two, and you've got it.
So at its core, recursion is basically just a function that calls itself to solve a smaller piece of the exact same problem. So instead of a loop that says, hey, do this 10 times, a recursive function says, okay, I'm going to solve this one tiny part, and then I'm going to call a clone of myself to go solve the rest.
Now, for this whole thing to not just, run forever, you need those two golden rules. First up, the base case. Just think of this as the big red stop sign. It's a simple condition that tells the function, all right, you're done, no more calling yourself. It's the tiny solid doll in our Russian doll set. And second, you have the recursive step, and that's the part that does the magic. It's where the function actually calls itself, but it hands off a slightly simpler problem each time.
Theory is one thing, but let's make this real. A classic textbook example is calculating a factorial. So, the factorial of 3, which we write as 3 with an exclamation mark, is just 3 times 2 times 1, which is 6. This kind of problem is it's built for recursion.
So check this out. When you ask the code for factorial of 3, it says, I can't solve that yet, but I know it's 3 times whatever factorial of 2 is. So it calls itself to find factorial of 2. That function then says, well, I'm 2 times whatever factorial of 1 is. So it calls itself one more time. Finally, factorial of 1 hits our base case. It knows the answer is just 1. And this is where the magic happens. It passes that 1 back up. The factorial of 2 call gets it, calculates 2 times 1, and passes 2 back up. And finally, our original factorial of 3 call gets that 2, calculates 3 times 2, and gives us our final answer, 6. It's like a chain of questions going down and a chain of answers coming all the way back up.
So that's recursion. But what's the other way to do it? Well, it's the method most of us learn on day one. It's iteration.
Iteration's totally straightforward, right? It's just using a for loop or a while loop. You set a starting point, you set an ending point, and you just chug along, step by step until you're done. To get a factorial, you just start a variable at 1, loop, multiply by 2, loop, multiply by 3. Done. It's simple, it's direct, no surprises.
And now, it's time for the main event, the head-to-head showdown. Both of these methods get the job done when it comes to repetition, but wow, they are fundamentally different, and they come with some really important trade-offs.
This table just breaks it down perfectly. Look at recursion. The code is often way shorter, more concise. It can be really elegant. Iteration, on the other hand, is usually more code, but it's often more straightforward to read. Now the big one, memory. Recursion uses a lot more memory, because every single time the function calls itself, it has to keep the original call open, waiting on what's called the call stack. Iteration, super low memory usage. And that also means iteration is generally faster, because it doesn't have all that overhead of making function calls. There's this quote I absolutely love that it nails the difference. Recursion is like poetry, iteration is like prose, right? Recursion can express a really complex idea in just a few beautiful, compact lines. Prose, or iteration, tells the same story, but it's more of a direct, step-by-step narrative. Neither one is better, they're just different styles. But here is the big, scary warning label that comes with recursion. What happens if you forget to write a base case? Or you write one that never gets met? Well, the function will just call itself, and call itself, and call itself, forever. Each call piles up on that call stack until you completely run out of memory and your program just crashes. That, my friends, is the infamous Stack Overflow error. It's like having a set of Russian dolls with no final solid doll inside. It just goes on forever.
So, with all of this in mind, how in the world do you decide which one to use? Well, it's not about which one is better. It's about picking the right tool for the right job.
You really want to reach for recursion when the problem itself feels recursive. Think about things like navigating a file system. You know, a folder inside a folder inside a folder, that's a perfect fit. Or working with any kind of tree-like data. In these cases, a recursive solution is often way cleaner and easier to understand. It's also awesome for any divide and conquer type of algorithm, where you're breaking a big problem into smaller, identical pieces.
On the flip side, you're going to want to stick with iteration whenever performance is king. When speed and memory are your top priorities, loops are almost always the answer. For simple, linear stuff, like just going through a list of items one by one, iteration is the no-brainer. And for sure, if you're dealing with a huge amount of data, iteration keeps you safe from that dreaded Stack Overflow.
So, at the end of the day, here's what it all comes down to. A great programmer doesn't have a favorite tool. They have a whole toolbox, and they know exactly when to use each one. Understanding the trade-offs between recursion's elegance and iteration's raw efficiency is what lets you look at any problem and choose the absolute best solution.
And that's pretty much recursion in a nutshell, a function that calls itself, guided by a base case and a recursive step. It's a different way of thinking, for sure. So I'll just leave you with this thought. The next time you're staring down a complex problem, ask yourself, does this look like a set of Russian dolls? Because you might just find a beautiful, elegant solution hiding inside.